Hello students, welcome back. We're going to be working on percent composition problems. We're going to try to calculate the percent composition of elements in a few compounds. I will be rounding the atomic mass number to the nearest whole number. I suggest having a periodic table and a calculator so you can follow along. I also recommend pausing the video, working the problem out, and then playing the video to check your answer. With that said, we'll jump straight into it. To solve these problems, we will need a formula, and that formula is the mass percent is equal to the element mass total over the compound molar mass total. Once you got that, multiply it by 100 to change it to a percent. So if you haven't, write that formula down somewhere, make note of it, keep it in mind. Alright, so our first problem is nitrogen monoxide. So I need to figure out what's the molar mass of this compound. Well, nitrogen is 14. There's just one of them. So that's 14 grams. Oxygen is 16. There's just one of them. So that's 16 grams. Together, we add those together, and that's 30 grams. To solve for the percent composition of nitrogen, nitrogen mass percent is equal to the elemental mass total, which is 14, over the total molar mass, which is 30. 14 divided by 30 gives me 0.466 repeating. So I'm going to round that to 0.47 times 100 gives me 47%. Next I do oxygen. So the oxygen mass percent is going to be equal to the element mass, which is 16, over the total molar mass, which is 30. 16 divided by 30 gives me 0.53 repeating, which I'll just keep as 0.53 times 100 gives me 53%. If you want to check your work, you can add those two values together. You should get close to 100. 47 plus 53 is 100, so my answer should be good. So now 47% nitrogen, I got 53% oxygen. Next problem, got ammonia, NH3, so let's break it down. Nitrogen is 14 grams. There's one of them, so that's a total 14. Hydrogen is 1 gram. This time there's 3 of them, so that's 3 grams. Together they make 17 grams. So the nitrogen mass percent is going to be 14 grams over 17 grams. 14 divided by 17 gives me 0.8235. Now I'm going to round that. I'm going to round it to 0.824. So 0.824 times 100 gives me 82.4% nitrogen. Let's do the next one. The hydrogen mass percent is equal to the 3 grams over the 17 grams. So 3 divided by 17 gives me 0.1764. I'm just going to leave it as 0.176. 0.176 times 100 gives me 17.6% for hydrogen. We add those two values together. 0.6 into 82.4 gives me 83. 83 plus 17 is 100. We should be good. Moving on to the next problem, NaCl, good old table salt. So first we'll break it down. Got sodium, got chlorine. Well, sodium weighs 23 grams. There's just one of them. Gives me a total of 23 grams. Chlorine weighs 35. There's one of them. Gives me a mass of 35. 23 plus 35 is 58 grams total, the molar mass of table salt. So let's figure out this percent composition. So sodium mass percent is equal to 23 over 58. And I'm going to get 0.39655. All those numbers round up pretty much. So I'm going to make this just straight 4.00 times 100 gives me 40% for sodium. Next, chlorine mass percent is 35 divided by that 58. Remember, 35 for the chlorine, 58 for the molar mass. 35 divided by 58 is 0.6034, so I'm just going to leave it as 0.603. Times 100, I get 60.3% chlorine. If you want to check your work, we add those values together. I get 100.3%. That's just due to a little bit of rounding. So we should be good still. Alright, next set. Copper 2 chloride. Let's break this compound down. So I got copper, I got chloride. Copper is 64 grams. There's just one. So that gives me a mass total of 64 grams. Chlorine is 35. There's two of them this time. So that gives me a mass total of 70 grams. So 64 plus 70 gives me 134 grams per mole. So now we fill in our formula and solve it out. So copper mass percent is going to be 64 grams for the element mass total over 134 grams for the molar mass total. 64 divided by 134, I get 0.4776. I'm around that to 0.480. Times 100, I'm going to get 48% copper. Next we do chlorine mass percent. Chlorine is 70 grams. Total molar mass is 134. 70 divided by 134, I get 0.522. 0.522 times 100 equals 52.2% for chlorine. Add those two values together, you get 100. You get 100.2%, so we should still be good. Up next, hydrogen peroxide. Let's break it down. H and O. Hydrogen is 1 gram. There's two of them. Gives me 2 grams for the mass. Oxygen is 16. There's two of them. It gives me 32 grams for the mass. Together we get a molar mass of 34 grams. So the hydrogen mass percent is going to be equal to 2 grams over 34 grams. 2 divided by 34, I get 0.0588. I want to round that to 0.06 times 100 gives me 6% hydrogen. Next is oxygen. So to find the mass percent, we do 32 grams divided by 34 grams. 32 divided by 34 gives me 0.941. So we keep it as 0.94 times 100. Got 94% oxygen. Add those together, you got 100%. Still should be good. Alright, moving to the next one, lithium hydroxide. Let's break it down. Got lithium, oxygen, and hydrogen. Got 3 elements this time. So lithium is 7 grams. There's one of them. So that's 7 grams for the mass. Oxygen is 16. There's one of them. So that's 16 grams for the mass. Hydrogen is 1. There's one of them. And that is 1 gram for the mass. So 7 plus 16 plus 1. Total molar mass is 24 grams. Now let's do the individual calculations. So lithium's mass percent is 7 grams over 24. 7 divided by 24, I get 0.292. Just going to go ahead and round that. I'll just leave 0.92. Or sorry, 0.292 times 100. And we get 29.2% lithium. Next up, oxygen. So we fill out our formula. The 16 grams divided by the 24 gram total. 16 divided by 24, I get 0.6 repeating. So I'm going to do 0.667 just to keep this decimal amount the same, keep it consistent. Times 100, I get 66.7% oxygen. Last one is hydrogen. So that's going to be the 1 gram over the 24 grams. 1 divided by 24, I get 0.042. 0.042, and I did round a 1 to a 2 because there's a 6 after it. Times that by 100, I get 4.2% for hydrogen. If we want to check our work, we can add all those values up, and we get around 100, so we should be good. Alright, last set. Next up is FeSO4, so let's break it down. Got iron, sulfur, oxygen. Iron is 56 grams. There's just one of them. Sulfur is 32 grams. There's just one of them. Oxygen is 16, and this one's there's 4 of them, so that should be 64 grams. We add those values up. I get a molar mass of 152 grams. Alright, now let's do our percentages. Iron percent is equal to its individual mass, 56, divided by the molar mass, 152. 56 divided by 152, I get 0.368 times 100. 36.8% for iron. Next up is sulfur. Sulfur weighs 32 grams. Molar mass is 152. 32 divided by 152, I get 0.211. 0.211 times 100. 21.1%. And that's going to be of sulfur. Lastly, we've got oxygen. Its mass is 64 grams over the 152. 64 over 152 gives me 0.421. 0.421 times 100. 42.1% for oxygen. We add all those values up, check our work, and we get around 100, so we should be good. Alright, I'm going to erase this one just so I got a little bit more room to work with the next problem. Alright, next up, calcium phosphate. Ca3PO4. Got a lot going on with this one. So I got a calcium, a phosphorus, and oxygen. Calcium is 40. There's 3 of them. Gives me 120 grams for the mass. Phosphorus is 31. There's just one of them. So 31 grams for the mass. Oxygen is 16. There's 4 of them. Again, that is 64 grams. We add those totals together. We add those masses together to get a total. It's 215 grams for the molar mass. Let's find our individual percent comps. So calcium percent is equal to 120 over 215. And I get 0.558. 0.558 times 100 is 55.8% for calcium. Next up is phosphorus. Got 31 grams over 215. And I get 0.44, or sorry, 0.144. 0.144 times 100, 14.4% for phosphorus. Lastly, we got oxygen. It's at 64 grams over 215 grams. And we get 0.2976. Just want to round that one to 0.3 times 100. We get 30% for oxygen. Add all those values up, and we should get around 100. We do, so we should be good. All right, next problem. Bromine gas. Just looking at it, I mean, what do you expect its percent composition would be? There's just one element. So if there's just one element in a compound, it is 100% of itself. We'll do it just to check anyways. So bromine is 80 grams. There's two of them. So that should be 160 grams for the molar mass. Using our formula, bromine percent, the individual element mass is 160. The molar mass is also 160. 160 divided by 160 is 1 times 100. We get 100% bromine. Alright, should be pretty easy on that one. Hopefully everybody followed that one. And the last one, we got C6H12O6. Good old sugar, some glucose. Let's break it down. It's got carbon, hydrogen, oxygen. Carbon's 12. There's 6 of them. 12 times 6, 72. Hydrogen is 1 gram. There's 12 of them. That's 12 grams. Oxygen is 16. There are 6 of them this time. So 16 times 6, 96. We add all those together, and we should get 180. Let's see, I've got room here, so I'll just kind of kick it to the side here. So 180 grams. Oof, that's ugly. Try that again. It's 180 grams. All right, let's break it down to the individual parts. Carbon percent, it's going to be 72 over 180. 72 divided by 180, we get 0.4 even. That's going to be 40% carbon. Next up is hydrogen. That's going to be 12 grams over the 180. So 12 divided by 180, I get 0.06 repeating. Do 0.067 times 100 is 6.7% hydrogen. Lastly, we got oxygen percentage. It's going to be 96 over 180. 96 divided by 180, 0.533 repeating, times 100, 53.3% for oxygen. I'd squeeze that in there. Add those values together, we should get around 100. So that is percent composition. Hopefully my writing wasn't too messy this time. But I hope this video helps. And as always, good luck on your tests.